Good evening. A very warm welcome to the General Society of Mechanics and Tradesmen of the City of New York. I'm Karen Taylor, the Program Director, and I'm delighted that you can all be here this evening for the second in our Landmark Lecture Series. The Labour, Literature and Landmark Lectures are supported in part by public funds from the New York City Department of Cultural Affairs in partnership with the City Council. For those of you less familiar with the General Society, a brief introduction. The General Society of Mechanics and Tradesmen was founded in 1785, and in fact we are now celebrating our 232nd year. Thank you very much. Today, our organization continues to serve and improve the quality of life of the people of the City of New York, our original mission, through its educational and cultural programs. These include our tuition-free Mechanics Institute, the General Society Library, our upstairs Lock Museum, and I encourage any of you who have not been here before and are curious to see the Lock Museum to please have a look after the lecture. And finally, our nearly 200-year-old lecture series, of which this lecture is part of this evening. You will find an informational postcard on your seat that gives you some more background information. And if you're interested in finding out more about the library, you will also find informational membership information. Sorry, that's too many informations, but you will find membership information on our front registration table. We're very pleased to present this series of landmark lectures in partnership with the New York Landmarks Conservancy, and I'd like to express our appreciation for their help and support. The 2017 Landmark Lecture Series is curated by Lisa Easton, a partner in the New York-based architecture and historic preservation firm Easton Architects. And now it is my great pleasure to introduce Lisa to you, who will introduce our speaker this evening. Ladies and gentlemen, Lisa Easton.
Good evening, everyone. Thank you for coming this evening. I'm honored to be a part of the General Society of Mechanics and Tradesmen's 2017 Labor, Literature, and Landmark Lecture Series. I love that tongue twister, alliteration. And when asked to curate the four-part Landmark Lecture Series, I wanted to bring together a group of individuals whose experience captures the essence of preserving our treasured landmarks, from technology of materials and methodology to advocacy and historic research. Tonight, I'm honored to introduce an incredibly talented colleague and friend, Robert Bates, principal at the architectural firm Walter B. Melvin Architects, specializing in complex restoration projects involving some of our most significant historic resources in New York City. Robert holds a bachelor's degree in architecture from Lehigh University and has been active in the field of historic preservation and building restoration for over 25 years. Specializing in exterior building envelope restoration, his notable completed projects include, here in New York City, include Grace Church, St. Thomas Church, the Cloisters Museum, McKim, Meade and White's 998 Fifth Ave, and tonight, the Donald Judd Home and Studio, which he'll be presenting. He's also presently working on the study and restoration of Kane Street Synagogue in Brooklyn, Central Presbyterian Church, and James Renwick's Smallpox Hospital on Roosevelt Island. Tonight, Robert will be presenting a case study on cast iron restoration, illustrated through the Donald Judd Home and Studio Restoration Project, in which he will share his methodology in approaching such a complex project and explore the complexities of removal, cataloging, refurbishing, and reinstallation of the cast iron features, elements, and structural systems hidden beneath this distinctive SoHo landmark. Tonight, it's my pleasure to introduce to you Mr. Robert Bates.
Wow, there's so many. I'm Robert Bates. Thank you, Lisa and Karen and the Society for inviting me tonight. I am going to speak about a case study on the restoration of the Donald Judd House at 101 Spring Street. Before I do that, I don't know how many of us are familiar with cast iron architecture in Manhattan. I'm going to assume that some of us aren't. So I'm going to give a sort of a thumbnail sketch of the history of that material and building methodology in New York. This is the guy who kind of started it all. His name was James Bogardus. And in 1850, he patented an idea to cast molten iron into architectural shapes that mimicked Beaux-Arts and highly stylized architectural elements of Europe. He was a great propaganda guy, and he's actually the fellow who basically invented cast iron facade architecture. This was one of his competitors early on, and then this fellow, Daniel D. Badger, took over and created a foundry and developed a catalog of architectural parts. And there would be column capitals, pediments, foliated lintels, shafts for capitals, and brackets, all of these wonderful architectural elements to allow architects to choose from his catalog pieces of architecture to apply to buildings for each of the cast iron pieces was noted to be very durable, maintainable, quote unquote, non-combustible, which is actually not true, as we learned later on. And so he really pushed the idea, especially in New York, of fabricating and installing beautiful cast iron facades over what would otherwise be fairly drab buildings. And these were for industrialists in the SoHo and Tribeca area. You may not know that when you walk south of Houston Street into SoHo, and before you get to Canal on the south and Crosby on the east and West Broadway on the west, you are standing in the cast iron architectural capital of the entire world. There's more cast iron buildings in that district than anywhere in the world. There's 500 buildings in the district, and a little less than half of them are cast iron facades. So Daniel Badger, this is the frontispiece of his catalog, which is really fanciful. And it shows the foundry on the base, the architects here in the middle with their plans out, the pattern makers up to one side, some of the assembly team on the right, smoke belching out of the foundry. Mind you, this was in Manhattan, and there were 14 other foundries in Manhattan that produced these things. I thought it was interesting that the clock on the wall says 10 after 5, but it's still a very busy atmosphere. And so this is a page out of the catalog, and architects would come in, meet with the pattern makers and the designers in the foundry, and they would pick and choose architectural components to assemble together to make a classical facade. This is another proprietary system which I can touch on now because it has something to do with the Donald Judd House. This is a cross-section of a sidewalk where the sidewalk is equipped with vault lights, and if any of us have walked through SoHo, we can see these vault lights with the little round bullet lenses, and that was meant to permit natural sunlight to descend into the basement area, which is fairly typical. What's a little bit different about this and the Judd House is that the basement floor is also equipped with glass planks, and that allows natural daylight to permeate through the vault lights on the sidewalk, through the basement floor, and into the sub-basement. And so this was at a time when all they had was gaslight to rely on. So the more daylight they could get into the building, the better. And if the Judds would ever let you into their basement, which has now been refurbished, on a cloudy day, you can walk around in the sub-basement without any electrical illumination. Another thing, cast iron, some people don't even know they're walking past cast iron buildings. And if you have a firm knuckle and a good ear, you'll be able to tell which buildings are cast and which are stone. You'll also notice that every foundry was very proud of their product, and they would put a maker's mark on the building next to the front door. And so this is one of the rare Daniel D. Badger maker's marks in Soho. This was a sketch that the architect Gaynor came up with for him to include in his catalog. And you might know this as a building on Broome. It's the northeast corner of Broome and Broadway. It's called the Howat Building. Some people call it the Hogwarts Building. And there it is standing in reality. And so store owners and manufacturers were very proud of these buildings. They painted them wonderful colors. They broadcast sand into the paint finishes to mimic stone. It was very fanciful, and it was sort of the American industrialist's chance to have an Italian Venetian palazzo right here in Soho, and this is actually mimicked after a library in Venice. And so during this time, you could do anything with cast iron. You could make it as foliated and Baroque as you possibly can imagine. And that was from sort of 1850 on. As we get further towards the 1900s, that style fell out of favor, as it often does. And we end up in the 1870s with the Donald Judd House. 101 Spring Street was designed by a fellow named Nicholas White, a little-known architect. In fact, only one other building exists in Manhattan, and one somewhere far away, and I think it's in Portland, Oregon. Nonetheless, he designed this building for an industrialist, a furrier, actually. And on the lower floors with the big windows was the showcase merchandise room, and the floors above were manufacturing. It's an interesting facade. It's very pared down from the sort of foliated facades we saw before. And from the top down, it has a tin plate cornice, which was very typical of cast iron buildings. All of the horizontal elements on the lower floors are applied cast iron decoration. Now, this material is only a 1/4 inch thick, and it's basically bolted to a substructure behind it. And for years, I walked around Soho wondering how all this stuff was put together, and I was lucky enough to work on this project where we got to take it all apart and put it back together. The architect was also showcasing, conceivably, the strength of cast iron, because if you look at the first floor columns, they're only about 8 inches wide, and they're very tall and slender. And as you ascend the building, the columns get fatter and sort of chunkier until you get to the top, where these sort of very strong-looking 2 foot wide columns are supporting almost nothing above them. And so this is the direct opposite of the way a loading pattern would work from an engineer's point of view. Normally, this should be upside down, and the big, heavy columns would be on the bottom, and they would lighten as they ascend. There's also a strange layout of, it almost implies that the architect did flip through a catalog and said, give me 5 pediments. You see 1 here and 3 on the bottom. Well, in fact, there used to be 3 on the bottom here, and there was some thought in putting this together. But the fire escape after the Triangle Shirtwaist Fire in 1911, the city mandated fire escapes, and so fire escapes were blasted through these wonderful facades in Soho and throughout the city. And a lot of the damage that we discovered during our survey was the result of the fire escape installation. Going down the facade a bit more, these are clear story windows at the base of the first floor windows. And on the interior of the building, the floor is open to, again, allow as much daylight into the basement. This is the vault light system, and these are monolithic granite planks that make up the rest of the sub-basement ceiling. And the other thing to notice, sort of as a precursor to a modern skyscraper, is that this facade is 54% window opening, and the rest is structure, which was very rare at that time. So we get into the survey. We were asked by the Judd Foundation to prepare a survey of the existing conditions and document them, catalog them, and then produce specifications for repairing the facade. And so I actually showed up here on a miserable, drizzly fall day back in 2005, and the scaffolding and the sidewalk bridge had already been up for about 6 years. And the netting was torn, and the boards were rotten, and here I was meandering around alone on the facade of this heaping, rusting piece of metal, and it was one of the best experiences I've ever had. So nonetheless, all you need to keep cast iron going, you know, this was built in 1870, all you need to keep it going is paint and caulk, and it'll just keep on going. It's not like steel that when it rusts, it delaminates to a structural degree and will disappear. Cast iron blooms as it rusts, that's the term they use, and it's basically rust dust, it's not rust scale. And if owners were just permitted to continually paint them, we'd have them in perfect condition for perpetuity. So Don Judd liked the way it looked otherwise, I guess, and he bought the building, I should mention, in 1968 for $69,000. And he made it his home and his studio. So nonetheless, when I did arrive and did a survey, we found all of this rust. We found that the column capitals and much of the decoration was just missing. And that was a result of the rust putting enough pressure as it accumulated behind these applied pieces, and it would push them off the building. And if the sidewalk bridge was in place when it happened, they would land on the bridge, and if it wasn't, they would land on the sidewalk. And Donald Judd was a collector of all things, including bits and pieces of cast iron that fell off of his building. In fact, when we did our inventory of the found pieces, we found more than we needed. And in fact, many of the pieces came from other buildings in SoHo, and he collected those as well. But you will notice that there should be a modillion, which is this bracket-shaped thing right here and here. The column capitals have all been shorn off the building. There's openings, there's gaps. Here's a corner of one of the pediments where, remember, these are hollow, as I mentioned. So there's enough space in here behind this, this profile that the rust accumulated to a point, the seams failed, water got in, things froze and thawed over time. And then we get these structural failures. Structural failures in decorative pieces. Again, these sort of abstract dentils under the third floor water table, that's one sort of triangular piece of cast iron, completely hollow in the back, held in place by a bolt that runs from here up through the soffit. And you can see how it's being pushed away from the building. Now, many of these pieces during my visit and subsequent visits I could remove by hand. And, you know, that's not good. Here's a detail of a column capital again that has disappeared. You know, cast iron is a very brittle material. And once it gets put under significant pressure from this rust jacking, it will simply break. And this packed material in here is all rust. And the missing rust in here was when I stuck my tape measure up inside there and pulled it down, and about a gallon of rust poured out over me and whatever else was around. Again, this spandrel panel is being thrust off the building by rust. This is what's kind of interesting. So the cast iron is brittle, and it doesn't work very well in tension. Works great in compression. The bolts that hold all this together are wrought iron, and that works very well in compression. So the wrought iron bolts that would have had their home at these holes were holding on for dear life as the brittle cast iron was being pushed off of the building. And eventually the bolts gave up, but they were the last things to give up, as evidenced by the little scallop failures here where the bolt heads would have been. Here's one that, you know, this is what the rest of them probably looked like 40 years ago. But we found this one bolt head intact, and it's trying its best to hold that expanding piece of cast iron on. And these scalloped failures are the result of rust building up behind. You can see how it overlaps the piece underneath it here. And so as this fascia filled up with rust, it caused enough pressure to break this off over time. This is the corner of Spring and Mercer. I don't know which floor it is, but you can see how this entire corner piece, which is about 2 feet tall and a radius of about 1 foot, is being pushed out towards the audience here as a result of all of those dynamics, and that the bolt heads are trying their best to hold everything back in place, but that stress is causing the pieces to crack. Again, just evidence of these poor wrought iron bolts working for a living. This one gave up as well. And so this was supporting one of these decorative modillions. This was a telling discovery, actually. And this condition that you're looking at directed the rest of the project. And so what we have here is a decorative spandrel panel, again, 1/4 inch thick material. Aesthetically, it's meant to spring off of a column capital beneath it. So that's how it would be done in stone. The column capital would support the spring block of the arch, and all of this would be in compression. So aesthetically, that's what they were after. But practically speaking, when the anchorage failed on this spandrel panel and those bolts that I described started to give up, this spandrel became dependent on the column capital below for bearing, and that column capital was not meant to bear any weight. This happened, excuse me, at every column capital on the building. And so we decided then we have to take these spandrel panels off. And if we could get them off, we could then paint the backs of them. And the wonderful thing about cast iron is that it's meant to be removed and replaced. It's bolted on. It's the IKEA assembly of 1850s. And we weren't afraid of this. And so we convinced the foundation that the right thing to do here would be to take these panels off, repair them, and reinstall them in their original locations. So we did a survey like architects do, and we do drawings like we do, and we came up with this sort of elevation drawing that shows all of the pieces in gray, which are applied decoration, would be removed. There are over 1,300 pieces, and they would be they're bolted on with flathead bolts, and the flatheads were covered with basically a lead paste to disguise them. And so we had to go in and dig out the paste, unscrew the bolts, and take each piece and put a dog tag on it, put it in a crate, and it was sent down to Alabama to the Robinson Iron Works for refurbishment. The turquoise, I don't know why we use that color, but the turquoise elements are decorative, but they are structure. So the columns at the building are all structural, and obviously they had to stay in place. Now, in removing basically 100% of the decorative cast iron and leaving the structure there, you would think that because there's structure behind the decoration, that we wouldn't have any movement of the structural frame. But nobody was willing to guarantee that. So if the decorative materials were actually providing some de facto lateral bracing to the structural frame, we didn't want to find out the hard way that when we brought the pieces back from Alabama, that the holes didn't line up. So the structural frame was braced with a very complex series of scaffold brackets designed by Plan B Engineering and Robert Silman Associates. And the good news at the end, you know, spoiler alert, we did come back and we put all the pieces back and the holes lined up perfectly. So this was the fun part. So we got to, you know, the mysteries of how all this stuff goes together, I was really looking forward to solving. And the minute we started taking this apart, I realized how naive I must have been, because it's not complicated at all. It's bolts and it's, you know, standard connections. In this particular building, the substructure is quite fine, in fact, and we don't get to see that. But if you notice, this is a water table on one of the floors. This is a bracket that supports the water table, and it's simply bolted to structural cast iron column. Each column is bolted at each floor level to the next one with bolts, 4 bolts apiece. Sometimes there are only 3 and there was 1 missing. And but the profile of this we thought was intriguing, because it does mimic the profile of the nose of the water table. This is completely unnecessary from an engineering standpoint. It doesn't need to follow that contour, but you know, when we discovered this, we thought in the spirit of the project, anything that we would replace would be of the same level of quality and design. Here you can see one of these brackets that's just about to peel off on its own. It weighs about 7 or 8 pounds, but it would hurt if it... Again, we start to discover how this is put together. This is the west facade. This is a cast iron spandrel beam, and that is the horizontal structure that spans between the vertical columns. And you can see here a little bit that this was all the brown stuff you see here was covered up. We uncovered this during our probe work. And you can see that the column has this decorative profile it was just easier to cast the column with a continuous decorative profile. Where it daylighted, we could all appreciate it as passersby. But where it was hidden, we couldn't. And it's just kind of interesting that all of this decoration exists behind what we can see as a visitor. So very simply, the structural system is a series of columns with spandrel angles, and each of these is a wooden joist that runs from the angle back to a masonry load-bearing wall on the east side. This is just an example of the fineness and distillation of the design, where this is a cast iron, the flange of a cast iron column, and into it they cast this little 3/8 inch shelf. And so this all had to be designed in the pattern shop out of wood, and then a sand mold was made from the wood, and then the cast iron was poured into the sand mold, sand because it's non-combustible. And this tiny little detail is representative of many that we've seen in this particular project, where they had the forethought to cast this 3/8 inch shelf to receive this 1/4 inch spandrel panel or soffit panel that rides up away from it. It's very Judd. It's very Judd, this sort of attention to fine-tuned detailing. This is just an example if we have woodworkers or metalworkers in the audience. This was just kind of an interesting find that, you know, nothing's perfect. You can make it in the shop, and they would do that. They would pre-assemble all these pieces in the foundry, ship it to the site. After the foundation wall was built, they would start assembling these columns on top of one another, and often they might not have lined up with one another. So these are actually cast iron shims. Now, we today would use PVC or cedar shakes for things like that, but they had the ingenuity to make shims out of cast iron, and they came in different thicknesses, 1/8 inch, 3/8, to get all of the floor levels level. So we found this building does not have a maker's mark on the front door. We had a lot of trouble finding out who manufactured the pieces. It didn't come from the Badger book. It didn't come from any well-known foundry. But we did find that JT and JB Smith was stenciled on almost all of the structure behind it. So the assumption is that the foundry that made the structure also made the decorative material. We also found a shoe. And so this is sort of a poignant reminder of the past of this building and who the labor force was, because this is a lady's shoe, probably from the turn of the century. And it sort of spilled out of a wall as we took some of the finishes off. And we all sort of brought it to the conference table and we sat down. And it was sort of sad, and it was reminiscent of a time that probably wasn't so nice for hard workers in the seamstress business and shirtwaist business. But then someone reminded us that it was always good luck to throw a shoe into the wall of a building for prosperity. And someone said it was the left shoe. And so we're hoping that that's what this is all about.
Yeah. Is that true now?
Is it true now? It's a urban legend, I suppose. This shoe is hard as a rock, by the way. But it's telling. Okay, so here's the denuded, one of the denuded floors of the building, and exemplifies the structural system again. Column-to-column connections were made with flanges that were cast into the original casting. In plan, these columns are C-shaped, so they're hollow in the back. Again, the spandrel panels and the wood joists. And so this brown area from here to here was where all of the decorative applications were installed. Then I tortured one of our draftsmen to try to come up with this IKEA-esque assembly pattern. And we really had to do this to figure out if we're taking everything apart. You see, the way it was built was from the bottom up, and all of the cast iron laps over itself to shed water. So we had to take it apart in a very sort of organized way to make sure that we didn't break any pieces because it was so brittle, and make sure we could put it all back together. So this is just illustrative of that process. Some pieces were so badly damaged that to remove them would mean they would fall apart. And so Robinson Iron came up with a solution to scan these with a laser scanner. Excuse me. So each of these little nodes here is a reflective decal that the folks from Robinson came up with a handheld laser scanner and produced a 3D image. Then they sent that into their CNC machine and they made a pattern from that, which was pretty high tech as far as we were all concerned. So these are all the pieces being reassembled for inspection in Alabama. The process that they used to refurbish them was to sandblast them down to bright metal, and then for a fairly inexpensive cost, they were able to do a zinc thermal spray. And if anyone knows anything about galvanic action, zinc corrodes in the presence of iron. And it's usually used to protect iron. So if iron begins to rust, the zinc will corrode in order to protect it. It will sacrifice itself. And so each of these pieces after sandblasting was hung up in a booth, and with this very loud, smelly machine, 2 coils of zinc wire were fed through a gun, and when the trigger was pulled, the zinc wires arced together and broadcast atomized zinc onto the metal piece. And that was a great thing because it extended the life of the material indefinitely. And it gave a very tacky surface to apply high-quality epoxy paints to. So these are the pieces going back on the building after redelivery, and these brackets are new, actually. The one that I showed you before, as I said, that this material is not great in tension. Almost every bracket was cracked up in this section here. So the folks at Robinson actually water laser cut these at minimal cost in the big scheme of things. And they are made of stainless steel. So here's just a couple of before and afters to conclude, but you recall this photograph, and this is how it ended up looking. And this is how it looks now. One thing about the paint color, it's battleship gray. The original paint color of this building was limestone, sort of a buff, and the windows were painted burgundy. Now, the foundation didn't want to go back with that, and although I secretly wanted to, but the Landmarks Commission approved the notion that the important history of this building took place when Donald Judd was there. And they allowed it to be painted the color it was while he lived there, which is battleship gray. This was obviously a pre-construction photograph. It's sort of like a wounded warrior bandaged and held together with tarps and furring. And here's our finished product. And before I conclude, I just want to have a shout out to Jay Gorman, who's in the audience, who's with FJ Siami, who is the construction manager that put this together, and to Guy Sichi, who is the artistic window manufacturer who manufactured all of these brand new mahogany windows. Thank you very much. I think we have opportunity for Q&A.
All right.
You were going to say something about fire.
Was I?
Danger, yeah.
Well, so Daniel Badger's catalog shows that cast iron is incombustible. That's one of his headings of his descriptions. And in fact, it won't go on fire, but it won't stand up to fire. And when put under particular duress, under high temperatures, it will break. And so that's probably what I was going to say about fire. Yes?
How long did the project take? Was it continuous? And what was the cost?
The cost for, well, first of all, the other person I didn't thank in the firm was ARO, Adam Urinsky and Jeff Hong. They were the lead architects on the projects, and so the interior of the house was also fully restored. I don't know what the cost of that was, but the exterior restoration was in the range of $5.5 to $6 million, including the windows. How long did it take? It seemed like forever, but honestly, it was one of the nicest projects I've ever worked on. But it probably took, I did the survey in 2005, and so there was a lull in between that and the start of construction. It was completed in 2013. I'd say it's probably a 4.5-year project, maybe 3.5 years, yeah. Sorry.
I was wondering, when you walk around SoHo and you see other cast iron buildings in the process of being renovated, what kinds of things drive you crazy? What is being done incorrectly?
Well, it doesn't drive me really crazy, but it would be nice where anchorage has clearly failed and you can see pieces misaligned. The popular solution is to slather them with paint. Clearly something is happening that causes that dislocation of units. And it would be fairly simple and not $5 million to simply pull the piece off, fix what's going on behind it, and put it back. And so it's just developing a knowledge of how these things are can be routinely disassembled and reassembled. And it doesn't drive me crazy, but it would be nice if more people knew, or building owners would know, it's not a big deal to unscrew this. You can't do that with a brick building. You can't do it with a wood building or a stone building. But this material, you can pull off, you can paint it, you can scrape it, and you can put it back on. And so it would be useful if more folks understood that. Yes. Oops, sorry.
Okay, I have a couple of technical questions. As genuine wrought iron was no longer available, what did you use for bolting?
Stainless.
And stainless steel.
Yep.
And a lot of these panels were obviously stress cracked. When you brought them down to Alabama, how did they repair those pieces? Because obviously they weren't making all new.
Right. It's a good point. We only replaced about 15% of those pieces. The cracks were drilled at their termination point to prevent it from continuing. And then they were backplated with stainless steel backplates, then countersunk flathead bolts filled to make them disappear, and then the crack was then basically puttied with an epoxy putty and sanded. These are not structural repairs. And welding structural cast iron is a really complicated thing that's particularly, we've been told, undependable. But none of this was structural. So we did do welding repairs on many occasions, but then they were they were ground down smooth, and they didn't provide any structural improvement. And stainless steel bolts were used everywhere.
I want to see if you have a confirmation of a legend that says that a few years ago, all the cast iron was taken down from one of the SoHo buildings. It was taken to storage somewhere, and all of it was lost. Is that legend or truth?
I don't think it's all lost, but it's been poorly handled. And I've seen pictures of the columns, and I don't remember the building. Do you remember the building?
I don't. It's on Grand, though. Yeah.
It was on Grand Street?
Yeah.
Someone in the audience might know, but that was a terrible shame. And the photograph I saw of it may have been prior to it disappearing entirely. But I remember seeing stacks of ornate columns piled up on top of one another. And there was even a discussion at some point that someone was going to buy it and refurbish it as a folly. And wouldn't that have been wonderful? But that's all I know. Yes?
I see there's a lot of pieces involved.
Yeah.
How was the original survey conducted for the building?
Well, it wasn't too high tech. We could see where all the joints were. We could number all the pieces. And we were able to walk through with a mallet for sounding dislocated pieces. And we simply numbered them on the elevation drawings that you saw, obviously at a bigger scale. But it's easy to quantify every piece on that building because you could see the bolt heads, you could see the seams. You knew that every piece of decoration was its own thing and could be taken off. So there were spreadsheets and all sorts of other things, but it wasn't particularly high tech. Back?
The original.
Yeah.
The bolting, was that all face fastened bolting with that lead putty that you referred to?
Yes.
So you just had to clear that out, and when you put it back as new, as renovated,
right?
You did the same thing with a face fastened.
That's correct.
And those were countersunk effectively.
Yes.
Okay.
Yeah.
And did they have any sealant or any putty seam to seam when they originally built it?
Yes.
And what was that material?
That was lead whiting. Mm-hmm. That was filled. Most of it was gone when we got there. And so we actually had a special team of caulking contractors come in and seal all those seams after the restoration, prior to the finish coat of painting. There was challenges with the countersinking of the bolts, actually, because the material's so thin. Like I said, it's only a 1/4 inch. So with a modern flathead bolt, think how far you can countersink that before the hole gets too big. And so we've had some recurring loss of the putty that we applied over those bolt heads because the depth of the countersink was too small. But the putty for the bolt heads, really the only purpose it serves is aesthetic. And so even in the original construction, the bolt heads on the upper floors weren't puttied at all. Those that a passerby could scrutinize were. But yeah, and I don't know, about a year after the project, we had some of those countersunk bolt head failures. And so we went back and put new putty in and sanded and painted them again.
Makes sense. I guess the only alternative could have been maybe, you mentioned at cracks putting a back plate, maybe at bolt hole locations putting a back plate so you can put a deeper countersink.
You know what? I think we might have done that in a few instances.
Interesting.
It's also important to note that these are bolts, they're not screws. So when this building was put together, someone had to be on the inside of the columns and the inside of the spandrel beams to put the washer and the nut on and tighten these things up. So we had to provide the same access. Fortunately, the interior was being renovated so we could get access to the backsides of all these columns and paint the backsides of everything. Guy? That's a great point. Bad. No, they weren't. Well, I mean, they were shored up, and the shoring had been there for some time. It's important to point out that the granite slabs, which are 5 feet wide, 11 feet long, 8 inches thick, were all pulled up and stored on site in order to pour a real structural slab that was properly waterproofed underneath it. But a lot of this, the structure that runs along the the side of the vault light, if you can recall the first photograph, the back end of those granite slabs rests on a B-shaped, lowercase B-shaped beam. And so it's shaped like that. And the granite slabs were resting on that. In turn, that beam was supported by fairly minimal round columns on the basement level, and then brick piers below that. And those columns were problematic. They were out of plumb. But the B-shaped beam actually was in pretty decent condition, but nobody could wrap their head around how to calculate its capacity because they don't make it anymore. So sadly, it's gone. And it's been replaced with a structural I-beam that's easily calculable. Yeah?
What kind of paint system did you use on the outside? What products did you use? Aside from the zinc primer, what paint system did you use on the outside? And a second unrelated question is, what's the load capacity of these restored sidewalk panels? The cast iron with the glass prisms.
Yep. So there's two kinds. Well, first question is we used Tanemic paint products, which is an alkyd epoxy-based paint. The exact specification I don't remember. 2 prime coats were applied in the shop, and then a finish coat applied in the field. What was the other question?
About the capacity of the restored glass.
So we were able to rely on the old code for the glass panels along the building, which is 300 PSF. The granite slabs would have to meet a 600 PSF load to take the accidental fire truck or delivery truck that would run up on top of them. What we have there now far exceeds that requirement. But the glass, we were permitted to keep the old code. And primarily because it was quite far from the edge of the sidewalk. There was a minimum dimension that we had to comply with. Yeah?
Is there any chance to not reinstall the fire escapes on the outside?
No. No, we needed that. The interior, the museum restoration needed that. Sorry.
I could take one more question.
One more?
I was just curious how you wound up with a firm in Alabama to handle the repairs. Are there more than one firm on the East Coast that does
There's not many, but as it turns out, what we really did was painted. There's lots of those firms. But the castings that we had to have done, as I said, we expected more, but Robinson was well suited to do the repairs and refurbishments and the casting. And so there are not many foundries that can do that volume of work. And so, you know, it was a big decision to make. The process, we interviewed several foundries, and the price was good and the quality was good. And Scotty Howell at Robinson Iron has admired the building since this New Yorker cover was published. And he was also a great friend of Margot Gale, who you might know was a proponent of cast iron architecture and basically saved Soho with James Marston Fitch and many other Soho artists from the destructive Robert Moses, who was going to build a highway straight down Broome Street and obliterate all of this wonderful architecture. Thank you.
Robert, that was absolutely fantastic. It was so comprehensive and so detailed. It was really a wonderful presentation. Could we all applaud Robert once again? Thank you so much. I'm sure that Robert will be happy to answer some more questions informally, but I would like to now and Robert, we'd just like to make a presentation to you before we round up the evening. So, Robert, thank you so much. Could we ask you to come up again? You may have thought you had escaped, but no. So this is Victoria Dingle, our Executive Director.
Robert, thank you. And Robert, and thank you so much for your wonderful presentation. And I've passed the building many times, and we'll look at it all the more closely. But what I'm really curious about is who does those windows? Those were the cleanest windows that I've seen. It's amazing. On behalf of the General Society of Mechanics and Tradesmen of the City of New York, founded 1785, we express our gratitude to Robert C. Bates, principal at Walter B. Melvin Architects, for his lecture, Cast Iron Restoration at SoHo Landmark, Donald Judd's Home and Studio, a Case Study, for his participation in the General Society Labor, Literature, and Landmark Lecture Series. So thank you.
Thank you very much.
Robert has obviously not attended our lecture.
Okay.
So, as everyone knows, that we have now conferred this upon you, that you are a lifetime member in the General Society Library.
Oh, my goodness.
Hereby conferred. And Meg Stanton presents you with your certificate, your poster there, a memento, yes. And
wow.
So thank you, thank you.
I have to say something.
Okay, please, okay.
This is when I get to thank my wife, who's sitting back there taking a photograph of me. Thanks for putting up with all the worry, and thank you, everybody, for this wonderful honor.